Hello, my name is Ardi and we are going to solve practice problem 10.2 from Sadiku book. So the question is calculate V1 and V2 in the circuit shown in the figure 10.6. Okay, so let's see. We are asked to find this voltage here in this node with respect to our current. Okay, let's copy the circuit and then enlarge it. Okay, we are given this diagram. So if we see here, we have the voltage in polar coordinates. The others is in rectangular or Cartesian coordinate. So for resistor, for inductor, or capacitor is all in the Cartesian coordinates. So I want to convert this into Cartesian coordinates. So first, voltage sources to here. Okay, the first is 75 angle of 0. This is easy enough. So this is in rectangular coordinate or Cartesian coordinate. This will be just simply 74, right? And then this one, let's see, 100, and we have the angle is 60 degrees. If we convert this into Cartesian coordinate, we will have the x value will be 100, cosine 60 degrees, and our y value will be 100 sine of 60. And if we plug this into our calculator, we will have this is as 50, and the y is 86 point this number 60 20. So if you write this as rectangular coordinate, this is the real part, so I will have 50, and this one is the imaginary part, so I will have plus 86.60. Okay, now we can do analysis like usual. So let's start. Maybe I think we can just use nodal analysis here, and let's assume the direction of the current. This one, this one, this one, and this one here. And because this is between two essential nodes, so I will have a super node here. Okay, we will have super node here. And let's start by analyzing KCL at the exactly super node. Okay, let's change the color. Use black here, and KCL said that the sum of the current that goes in is equal to the sum of the currents that goes out. And the only current that goes in is from this voltage, but this voltage is this node here, 75, minus this node here, 1, divided by the resistance between it, which is 4. And that is the only current that goes in. The other current is going out, so let's start from here. This current here, and that current is V1 minus 0, so we will have V1 divided by this inductor here, which is J4. Okay, now let's move on to this current here that pass through that capacitor, and that will exactly V2 divided by the value of this capacitor, which is minus J1. Or we can just move this sign here. So we will have that is S minus. And the last one is that pass through this resistor here, which is V2 over 2, right? We'll have V2 plus V over. Okay, now let's simplify. What can we simplify from here? Okay, now we have 4, J4, J1, and 2. What can we do from here? I think we can remove the denominator by multiplying all of this by J4. Okay. So I will have, let's see, this J4 will cancel that 4. So I will have 25J minus JV1, right? Or I think maybe we should write the J in. So let's just write J75 minus JV1, and this J4 will cancel with this, so I will have only V1. Then here J1 and J4 will cancel into 4, so we'll have minus 4V2, right? And then for this one, this will cancel into J2, so I will have plus J2. Okay, now let's group that V1 and V2. So let's mark all the variables here, not to be confused with another letter J. So J is a number, not a variable, right? So this mark yellow here is all variables, so we can group this to the right hand side. So I will have this one, maybe J5, J75, sorry, and then plus V1 plus JV1, right? And then the rest of it is still minus 4 V2 plus J2. Okay, let's mark the variable so we don't get confused again. And so we will have J75, and we can take out that V1 outside the bracket. So I will have this is S1 plus J, right? And the second one we will have minus, or maybe I just want to write it as plus. So I will have minus 4, then plus J. Okay. And this will be multiplied by. Okay, this is the first equation that we have. So we'll have this, all of this. Let's put it on a box as equation number. So let's name this equation as equation. Okay, because we have two variables, we need two equations, so we can take a look at the inside of the supernode, right? So the difference between V1 and V2, so we'll have V1 minus 2 is the value of this. So I will have that is P plus J 86.6020. So from here we have two equations with two variables. So let's name this as equation number 2, and our V1 and V2 is our variable. So now let's copy the equation number 1 and number 2. This, see if I can get anything meaningful from here. Okay, let's copy paste that. Okay, maybe format this one. Into this one. Into this one. Let's just ignore that. Let's just focus on equation number 1 and equation number 2. Okay, to make it easier, I want to rewrite this in the matrix form. So I will have 2 by 2 matrix, right? So I'll have 2 by 2 matrix. Then we have a vector which is contained of V1 and V2. And first thing is to look at the coefficient of the first equation, and we can insert this into our matrix. So I will have 1 plus j here, j, and then this one minus 4 plus j2, and then I will have v1 minus v2, so the coefficient is 1 and this one, and this will equal to the right hand side of both equation, the constant part. So for the first one I will have j 25, and then for the second one I will have 50 plus j 86.6025. Okay, now this matrix is hard to do it by hand, so I will have to use helpful tools, which is MATLAB. Let's use our MATLAB here. Okay, this is, I have my MATLAB. Let's erase this first. And we do here. Where is my MATLAB? Okay, let's write that first. So our A matrix is the matrix on the left hand side, so we'll have 1 plus j, and then minus 4 plus j multiplied by 2. Then on the second row we will have 1 and minus 1. Okay, that, and the right hand side I will have the matrix B is j multiplied by 75. I will have a multiplied by 75, and the second row will be E plus j multiplied by 86.0. In this number. Okay, that is good. So let's find the solution. A backslash b. So I will have that is my solution. So let's maybe copy that. So you need to open the MATLAB. This one. So let's paste this. So we will have this one. So from here, from MATLAB, I will have v1 is equal to 33.6325 plus j 0.692 volt, and then V2 is minus 16.3675 plus J 1667. Yeah, I mean it is 4 point. Just move that away a bit. Okay, 4 here, and the unit is 4. Okay, so we have this value. This should be the final value of 1 and V2, but in the problem the answer is given in the polar coordinate, so we'll have to convert this one into polar coordinate. So let's convert this. Okay. And what tools that we can use? We can use power map. Okay. To convert from Cartesian to polar, we need to use cart to pole, and then the value is 33.625 and 90.692. Okay, then we will have this one is the angle in radian, but this is the amplitude, and then 4. Okay, so now we will have the amplitude is here, but the theta is in radian, so we will need to convert it into radian. Yeah, I mean convert to degree, radian to degree from this number. Okay, so I will have the amplitude, it will be 96 point something, and the angle will be 96 point something. Is it correct? Let's see. Yeah, it's correct. Okay, let's just copy the value from lab then. Okay. Okay, now from MATLAB I will get the V1. Is 6.8, and the angle is 96.8, and then the angle is 69 point, and the unit is volt. And we can play the same game for V2. Let's again use MATLAB. Let's use the same function, up to pole, and just change the value. Okay, this is minus 16.675. Yes, 4.1667. Okay, but the theta is in radian, so I will make this into this one. Need to convert this into degree. So I will have that value. Let's copy that. Okay, we don't spend anymore. So we will have V2. The amplitude is 16.9, and the angle is 165. And if you see from the answer here, we have the same answer here. So that's all. I hope this helped you solve this problem. And then thank you for watching, and bye bye.